Hey Bab, Sensei, Nanobubble has been around for a long time. For a long time. I don't see much.
No, it's starting to be used in various places.
Is that so?
To a shower, bath, washing machine, and surprisingly familiar it's adopted.
Ah, you may have seen TV commercials such as shower.
But, in fact, there are even more amazing nanobubbles.
What is a great level of nanobubble?
Something like it is used in a shower or a bath, the density is completely different.
Yeah. I don't know what it is.
So let's explain what is nanobubble. First of all, nanobubble is so-called invisible. This is a small foam, which is ultra-fine bubble, I'm told, or nanobubble, both say the same, the diameter of the nano-level small bubbles.
Ultra-fine bubble? Why do you say different ways to be the same? It is somewhat complicated.
In the past, the word nano was said to have a negative image. Japan, who had been there and was looking for words that would change ultra-fine, gave me a ketai name. But both ultra-fine bubble and nanobubble, I'm talking about the same small bubbles.
I see, that's it. But various companies are making nanobubbles, right? Isn't nanobubble made in the world?
Japan is the most common company that makes nanobubble. Companies that make nanobubbles in the United States and Europe, there are many.
Nanobubble is made in the world, but when so many companies are making nanobubbles, I don't know what kind of thing is good.
As a difference in the quality of nanobubble, first of all, the amount of bubbles is very important. Still, it can't be used unless the foam can be easily made and the product is not cheap. This is also important.
A cheap, easy to make, and a large amount is good. I feel like I was told something very natural. Is there a company that can make such a product?
Actually, I succeeded in developing such an ideal product at a Japanese company. There is a company.
Really? Isn't that amazing?
Yeah, this is really amazing.
By the way, what kind of place is amazing?
First of all, the amount of bubbles is larger than other ones.
It's even more, but you can't see nanobubble, right? How do you know the amount of bubbles?
You can't measure it properly.
Then the amount of bubbles is all the company. Is it saying something appropriate?
Certainly I can't measure accurate numbers. I can't measure it all.
What do you mean?
The way you can do reliable measurements, the status quo has not been confirmed yet. Among them, the most reliable way is now nanobubble, called the ISO TC 281 committee. The most accurate method that the chairman who made the standard came up with is the most accurate, you have been told.
I guess it was that kind of thing. So the way the chairman thinks. How do you measure?
First, prepare pure water that does not contain anything at the nano level. After that, put the nanobubble in the water and measure the number. When the measurement is over, erase the bubbles. If the measurement value is the same before and after putting in the foam, you can get an infinitely close number. This is the best measurement method so far.
But why do you need to erase the bubbles? Is it not good to simply measure the number of foam after simply putting it in?
No. That's a big mistake. Because nanobubble is an invisible small bubble. When trying to count the number of bubbles in the water, is it a bubble or a small garbage? The current technology is indistinguishable.
I see. The garbage does not disappear, but if it foams, it will definitely disappear.
Such that. So the measurement value has not changed before and after putting in the foam and putting it in. I need to see.
But how do you erase such a small bubbles?
Slowly freeze the water and slowly dissolve. By doing so, the bubbles will disappear.
There is such a way to erase such a bubble. Then, how many bubbles in the world are in the way of measurement? What is it?
Now, for 1 milliliter, the density of 10th what is announced is the highest density.
10/10. There is no pin at all.
That's right, tens of millions of bubbles of 10 in 10 are tens of millions of sugar. It's packed with bubbles.
Tens of millions. Is that not enough?
Yes, at this point, it's a great number of foam. The 10-sized foam of 10 is one bubble basketball. If you think about it, the distance to the next bubble is it's about one Tokyo Dome.
Well, what is the one for one Tokyo Dome? What do we do?
In short, the story of density. When one foam is replaced with a basketball size, it's the idea that it's about that distance.
Oh, that's what. Then it is easy to understand. But when I say so, I guess the 10th power of 10 suddenly is not amazing. I thought.
That's not the case.
So So how far is it a 10 shift?
When it comes to the eighth, it's about Germany tropical islands. It shrinks to a sense of distance.
Oh, it's a tropical island. I don't know.
I guess it's about Yokohama Arena in Japan.
You should say so from the beginning.
I'm sorry, and when this becomes more tenth, it's about a school gymnasium.
Still, it feels like it's far away.
I agree, but at this point, the number of bubbles is about 1 billion per grain of sugar. It's so secret.
1 billion. It's a tremendous number of bubbles.
If 1 billion bubbles are contained in the sugar, it will be quite high density.
What about 10 on 10?
Do you want to know?
A little bit. Please tell me as soon as possible.
I understand then about the 10th board of the main subject. First, the distance is finally about a general 2-story house. If the distance is shortened so far, a considerable number of foam, it can be said that you can make it secret.
Certainly, it is easy to imagine if that distance.
But in fact, there is only one ball in a 2-story house, not if it was 5 times 10 apostrophe 10.
Yeah. What do you mean?
I want you to imagine a house like 4 LDK when it comes to 10. This is one ball in each room. It looks like a certain image.
It's pretty amazing.
Apparently I don't really understand the greatness of this. Then, can you see this?
Yeah.
This is the sense of distance of the ball I just talked about.
I also imagined a picture like this.
If you look at this from here, if you look at it. Yes. What a 10 minus 10 boarding the bubbles are secretly secret with such a close feeling. That number is 10 billion.
10 billion. I can't believe there are so many foams.
But if this is 10 9 squads.
It has decreased a little.
This is about the eighth of 10.
It suddenly decreases so suddenly.
There are so few when it comes to 10th.
When it comes to 10/7, is it so sparse?
Yes. Did this convey the greatness of the density of 10 on 10?
I understand very well. It's really amazing.
This number is said to be the last minute where foam can be scattered.
Is there a limit to making bubbles?
That's right. Actually, the negative charge is charged on the bubbles.
But, how does the limit amount relevant?
By being charged with this negative, what will happen if the foams stick together?
Yeah. I am sorry, I do not understand.
The minus electricity rebounds like a magnet. I'm sorry.
I see. In other words, the foams will rebound. Even if you make a bubble anymore, it will collide and break.
Correct answer. I can't reproduce it with the current technology. The limit of bubbles is probably about 12 to 10 to 10, you have been told.
I understand that. But what would you like if you could make so many bubbles?
That's a good question. So what do you think foam in the first place?
I wonder what it is. The air that has been rounded underwater. What is it?
That's right. To be precise, it's a gas that doesn't melt in the water.
What is it?
This gas is important. So is this an individual around me? Is it your gas?
It is gas.
In other words, foam is like oxygen or nitrogen. It's a gas.
Well, I can't see the story. In other words, what does it mean?
In short, make oxygen a high-density nanobubble by putting it in the water. Underwater microorganisms can be active and can be activated. Activated microorganisms break down the garbage and dirt in the water. As a result, you can purify the sewage. Using this to clean up ponds and disposal pumpkin, you can do it.
That was it. Nanobubble is amazing.
Yes, nanobubble is a really amazing technology.
With such a great technology, the sea can be beautiful.
Certainly, you can clean it.
Yeah. That's how to include it.
In fact, many companies that manufacture nanobubbles in the world you can't manufacture a large machine that generates nanobubbles.
Why?
There are various problems. In the first place, it is difficult to increase the size of the machine. Is it a big problem that it costs a huge cost?
Is there such a problem?
But the technology of nanobubble made in Japan is amazing. Using a material called carbon ceramic, you can make a large machine that generates nanobubbles. If you use this amazing technology, it's a breakthrough that can be cleaned in Tokyo Bay.
So are you actually cleaning Tokyo Bay?
No, it's still.
Why aren't you doing it?
Well, that's, somehow, adult circumstances.
Yeah. Adult circumstances? I do not understand that well. Tell me.
But the technology of nanobubble is showing a clue to playing an active part in a wide range of fields. It's used to grow vegetables besides purification.
Is it used to grow vegetables? Why is nanobubbles used to grow vegetables?
That is the fun after the next time.
Please tell me without a lot.
Nanobubbles are really incorporated in various fields. It may be actually used after the next time I'll explain it, so it's fun.
In that case, it can't be helped.
So did you understand nanobubble so far?
Yes, teacher. It's such a great technology, but it's not yet popular in Japan. It's strange.
It's still a developmental field. Because it is a technology that can be applied to agriculture, aquaculture, livestock and medical care. It is more and more expanded in the future due to practicality. I think it's a field.
I may be able to make a lot of money using nanobubble.
Let's start by purifying the dirty heart with foam. I wonder if I can talk about it next time.
What is that?
Then look forward to it.